In our introduction to mechanics, we discovered that there are 4 ways to describe the motion of an object. We learned that you can talk about motion with language, with diagrams, with graphs, and with algebraic expressions. And in this video, let's take a look at the diagrams of motion that we might be able to use. The world that we study in physics is a physical world. It's a world that we can see. So if we can see it, we certainly should be able to visualize it or draw pictures of it. If we seek to understand it, then that understanding ought to involve those visual representations, those pictures. So as you continue to pursue your understanding of physics, be thinking about your ability or your lack of ability to visualize what you're studying. And there are a couple of very common diagrams that we're going to use, and let's take a look at those real quick. Two types of diagrams that are in common use are ticker tape diagrams and vector diagrams, and let's take a look at both of those individually, and I think they'll make some sense. Let's start with ticker tape diagrams. Well, all right. So let's draw a line across here, and then let's imagine that we're in a car. Let's say we've got some kind of little automobile here, and y'all forgive my artistic ability. So here's our little car that we've got. And let's see if we can get all this to stay together. There we go. All right. And so let's say that we're in our car and that we want to go to the left. So if we've got a speed, if we're moving and we're going to the left, then that's a velocity. Velocity because we have both. It's velocity because we have both the speed and a direction. All right. Now we haven't specified what the speed is because in this case we're more interested in talking about the direction. So we have a speed of some kind and a direction moving to the left. Now let's also consider for just a minute, and let's pretend maybe this car has a little oil leak. And so if we're driving down the street at a constant speed, then as the car goes down the street, it's going to drip, 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 drip. You get the idea. Now if these drips are evenly spaced, let's say between each one of those intervals is 1 second. So this is 1 second of travel, then the second, and the third second, and the fourth second. And so if the distance per time as we move across is constant, then we could say that this is constant velocity, right? Are you with me so far? So let's put this down. Let's say this. Let's say we've got constant velocity. We have no acceleration because we're moving at a constant speed. All right. So when these ticker tapes are evenly spaced, we have a constant velocity. All right. But let's see what happens maybe if we're not moving in the same manner. So let's put another line down here and take a look at our car again. Let's see if we can copy that thing. Hey, we're going to look out here. So here's our same automobile, and we're going to say we have the same velocity. All right, we're moving to the left again. Except, let's say this time we've been at a stop sign, perhaps, or whatever, or a street light, and normally we accelerate. And so while we're sitting at the stop sign, this thing's just dripping oil all in one spot here, right? And as you take off, we always go a little faster. And as we go down the street faster and faster, these oil drips get farther apart. Do you see that? Now, they get farther apart, but let's think about the time interval. The time interval is the same between each drip. So this is the first second here, and the second second, the third second, and the fourth second. Now, if we're going a different distance in the same amount of time between each one, then you might recognize that as an acceleration. All right? So with this ticker tape and the dots getting farther apart, we have acceleration. Acceleration. There we go. So this is accelerated motion. But acceleration in which direction? All right, let's think about that. Well, we're moving to the left and accelerating to the left, so this is acceleration to the left. Or we could also say that this is negative acceleration, because if we're on a number line, all right, then this would be in the negative direction on a number line. Hope this is making sense. All right, now we've got another scenario that we could have here. So let's look at it. Same thing, all right, and we got our same car. Let's see if we can copy it again. Same car, except this time, and same thing, we're moving to the left, so our velocity again is to the left, except this time, let's say that we're headed towards a stop sign, perhaps, so we're already going fast, and so our drips are far apart. But as we get close to the stop sign, then what do? Our drips get closer and closer together until ultimately we stop here. So is this still acceleration? Well, yes, it has to be acceleration because our velocity is changing. So we still have acceleration, but it's not the same as the acceleration in the previous example. This acceleration is in which direction? Look at how the dots open up. They get bigger going back to the right, don't they? So the acceleration is to the right. So in this case, think about it. We're moving to the left, but we're accelerating to the right in which direction? If this is a number line, we're accelerating towards the positive direction. So that's a good example of how we could use ticker tape diagrams. I hope that makes some sense. We could make these same things moving up or down, whichever way you wanted to go. But I think this gives you the basic idea. All right, so let's take a look now and see what we can make sense of when we think of vector diagrams. I think we've learned so far that a vector is something that has both magnitude and direction. Magnitude and direction. Vectors have magnitude and direction. All right, let's see if that, vectors have both magnitude and direction. There we go. All right, so we've used arrows to represent that, haven't we? So an arrow has both magnitude and direction. Well, how does it have magnitude? We can make arrows different lengths, can't we? And also, if we wanted to, we could make them different sizes. Let's make one really big so you can kind of see it here. All right, there's a great big one. So if we look at these examples across here, this arrow has more magnitude than this one because it's larger. And as we go, this one has even more magnitude because it's longer. Now, sometimes if they're size, we could use this one, and this one would have more magnitude because it's larger in size. So there are several ways that you can depict magnitude and direction using these arrows. Let's get these out of the way. Let's use it in conjunction with the same example we had with the car. Whoops. Let's make this a more reasonable size. What do you say? All right, so here we are. Let me see if I can go copy that car. Here we go, got the car copied. But instead of using those little dot diagrams, let's use these vectors, all right? Let me get my arrow. All right, let's take a look at this. In the first one, we talked about the oil drip. But let's say in this one that we don't use an oil drip, all right? We can just use vector arrows. And if these arrows stay the same size, and we put them in the same direction, all right, then we get the same effect that we had if we were using the oil drops. I think that makes sense to you. All right, so let's leave it at that. Now, what if we were back in the same position we had? Got another one here. All right, let's copy our car back down here. Again. Oh, and we said, okay, so we had a left velocity here, and let's draw this back up there. This was constant velocity, wasn't it? Constant velocity. All right. We had no acceleration there, did we? All right, so let's take a look down here on this bottom one. Well, we still have a velocity to the left, all right? But what if we want to show an acceleration? Remember previously we did this and we were speeding up, weren't we? All right, so we've got an arrow, little one, but the next one, remember we're going a little faster, and then we're going a little faster, and then we're going a little faster, and then even faster. And so in this one we have a velocity to the left, a velocity to the left, and acceleration to the left. I'll leave that because I'm running out of time on my video here. All right, so let's go in the third example. Same one we had earlier. So we've got the car, all right, and we're moving to the left again, so we have a velocity to the left. But remember that example that we were trying to what we were trying to do was show acceleration back to the right because we were slowing down, weren't we? All right, so how was that? We had a big acceleration to the right, and then it got smaller and smaller and smaller, smaller and smaller. All right, and so in this one we had a velocity to the left and an acceleration to the right, and that might be a way we would use vector arrows to show the same thing. All right, so take a look at this. We have the vector arrows, and then we have the ticker tape diagrams, and both of those were ways to represent the motion, in this case of the automobile. I hope that makes some sense to you, and there you go, diagrams of motion.